aspirants, कैसे हो आप सब? We are back with our series of lectures on shortcut tricks for this IIT JEE and other competitive exams. Today we are going to see this shortcut tricks for this complex numbers previous year questions. So let's get started. See this complex numbers a plus ib. This is the real part and this is the imaginary part. Based on this, there will be many questions. Some 2-3 questions will be asked in JEE mains. So first question, to find the square root of 7 plus 24i. So here there is a small shortcut trick. Whenever, see, 7 plus 24i, right? So what we need to do here, the shortcut trick is to find root of x plus iy. First we have to find root of x plus iy. Some number x plus iy is given and if you need to find this, first what you do is you have to apply mod y by 2. Okay, then see here mod y by 2. So mod y is what? 24. 24 by 2 is what? 12. And then we have to apply factors for this. Okay, in such a way that the difference of the square of these factors should be equal to the value, okay, of x. Okay, see this one factors, I will take 4 and 3. So the difference of the squares of these factors, 4 square what? 16, 3 square what? 9. So what I got? 7. The same 7 itself here. So we have to arrange this in the form of factors so that I will get this value. So 12, 4, 7. So here my answer here is plus or minus 4 plus 3i. Okay. Next. See again similar model. Square root of minus 5 minus 12i. Okay, we will write. So minus 5 minus 12y, I already told you we need to find mod y by 2. How much? 6. Now I have to write the factors of 6 in such a way that the squares of the difference between those numbers will be equal to this value x. So I will take 2 and 3. 2 3s are 6. So 2 square 4, 3 square 9. 4 minus 9 is minus 5. The same number here. So my answer here is plus or minus 2 minus 3i. Okay. Next. See here, if mod z plus 4 less than or equals to 3, then maxima and minima value of this one. So here there is a shortcut trick. Okay. See, if mod z1, okay, if z plus z1 is less than or equals to x, then to find the maximum minimum of, to find max or min of mod z plus z2, we write mod z plus z2 in such a way that it is mod of z plus z1 plus or minus z3. Okay, so we write this one in this way. Now maximum value of mod z plus z1 is mod x plus mod z3 and minimum value is mod of mod x minus mod z3. Very important. Okay, see here we need to find the value of this mod z plus 1. So what I will do, I will write mod z plus 1 in such a way that mod z plus 4 minus 3. Why? I have to write this one in this form, mod z plus z1 plus or minus z3. So now we need the maximum value. So maximum value is mod 3 plus mod minus 3 is equal to 6. Again minimum value mod 3 minus mod minus 3 is equal to 0. So from here, okay, this is the answer. Next, see again similar model question. All these are previous year questions, very important. So here mod z plus 3 value we need, and this is the first statement given, and find maximum minimum. So what I'll do is mod z plus 3, wait, I'll change the mod z plus 3, we'll write it in such a way that z plus 4i plus 3 minus 4i. How we wrote? 4i cancel, z plus 3i, the same, the question itself. So the maximum value is 3 plus mod 3 minus 4i is 8. Okay, why? What is the value of mod? Root over a square plus b square, this is 5. So 3 plus 5 is 8. And minimum value is mod 3 minus 3 minus 4i is equal to, again this is 5 and this is 2. Okay. Now, so what we done here, the main problem here for this kind of questions is, whenever we see the complex number, first thing we need to remember that it should not be it should not have this imaginary value in the denominator. We know the shortcut tricks, that is okay. If we don't know the shortcut tricks, if we are doing the direct method, whenever you don't find your answer in the options, first make sure that imaginary value is not in the denominator. Okay, that can help it. Next one. See again, difference between greatest and least value. Same again, mod z. I'll write this in this form. So mod z minus 3 plus 2i plus 3 minus 2i. Okay, so what is the maximum value? 4 plus root 13. How I got this root 13? By using what? The mod values. So mod a square plus b square, mod 3 square 9, 2 square 4, 13. So this value I got 13. Okay, so this is for the maximum value. Now what is for the minimum value? Minimum is equal to 4 minus root 13. So what is the difference between these two? 2 root 13 only, right? 4 get cancelled. Next. Now directly, this is the direct question. Mod z minus 1 by z. So here the shortcut trick is, whenever mod z plus 1 by z is equal to a is given, then the greatest or least values, means for example, if the greatest value is asked, means greatest or max is asked, the formula is a plus root over a square plus 4 by 2. If min or least is asked, the formula is a minus a plus root over a square plus 4 by 2. Okay, now here what it is asked, maximum, minimum, something is given. So first we will find max. Max is equal to 1 plus root 5 by 2. So in this way we can get the answer directly, and you can check the options. See, this one we can directly do this by substitution method. So what we will do is, let x value is 1 and y value is 0. So what z becomes, z is equal to x plus iy only, right? So this becomes 1. So and z power 1 by 3 is 1 power 1 by 3. 1 power 1 by 3, that is omega. We know that cube roots of unity. So minus 1 by 2 plus I into root over 3 by 2 is equal to p plus iq form. So this is p and this is q. Okay, now so x by p plus y by q divided by p square plus q square, I will directly get, means only by substitution. X value is 1 by p value is minus 1 by 2, minus 1 by 2. I will write this 2 here because of this what, reciprocal, and plus y value is 0, so the entire value will be 0. I am not writing it, by p square plus q square. P square is this one, q square is 3 by 4, so this is 1 denominator, no need to write. So I will get a minus 2. Okay, now let z and omega are non-zero complex numbers such that mod z mod omega are both equal. Now we have to find the arcs. So here let z is equal to 1 plus I. So what is the r? That is pi by 4 tan inverse b by a some model. Okay, so next thing is omega minus 1 plus I, again arg is 3 pi by 4. 3 pi by 4. Okay. So here z is equal to 1 plus I, that is minus of minus 1 minus I, that is minus of omega bar. Okay, this is just like a static one. See next one. This is very easy. This is direct static one. Anyway, we will prove. Since mod z is equal to 1. So I think let z may be I. So then z by 1 minus z square is equal to I by 1 minus I square. I square is minus 1, I know. This is I by 2. This is imaginary. So all the values of the given expressions lies on y-axis. Okay. Next. See here, if alpha beta are the different complex numbers, mod beta is equal to 1. Then we need this value. So what we do here is, let alpha is equal to I. We take let alpha equals to I and beta is equal to minus I. Just directly substitute these values in this. Okay, mod minus 1 minus I minus I by minus I by 1 minus I square. I square is again minus 1. So this is 1. Okay. Next one. If mod z is equal to 1 and omega is equal to or w is equal to some value, and in this kind of question, see, just from the previous models we are trying to do what here is mod z is equal to I, we are taking I, so w is equal, just substitute I minus 1 by I plus 1. I already told you in the beginning that in complex numbers denominator should not have an imaginary value. So what I will do is I will rationalize. Okay, I minus 1. So this is I minus 1 whole square by a plus b into a minus b form in the denominator. So this is a square minus b square. So I square is minus 1, we already know. So this is a square plus b square minus 2ab by minus 1 minus 1. So I square is minus 1 plus 1, both gets cancelled. So here is minus 1 minus 1 minus 2. Minus 2 minus 2 get cancelled and I will get as I. So here what is the real part? This is the imaginary part. So 0 plus I. So real part is what? 0. That is our answer. Okay. See, here is the next question. See, the question is very big and the answer is too small. So if z1, z2, so on, zn are in what? GP. This is the keyword here. First term as unity. So that sum is 0. Now if this value represents the polygon vertices, and we have to find the distance between in-center and the circumcenter. Okay, it's very small shortcut. Let z1 is equal to 1, already given. Z is equal to omega. Z3 is equal to omega square. Now z1, z2, z3 are the vertices of an equilateral triangle. Okay, this is some polygon is given, and since these are cube roots of the unity, now z1, z2, z3 are the vertices of an equilateral triangle. Then distance between, for an equilateral triangle, the distance between what? In-center and circumcenter is 0. Okay, see, the question is very big and the answer be done by small trick. See the next one. If omega is an imaginary root of unity and the value of this series, okay, so we can't do the, and whenever the question is like for so on up to n terms, we take 2 terms, 3 terms, like that. So here let n value is equal to 2. So what is LHS becomes 2 minus omega, 2 minus omega, 2 minus omega square. Okay, so this is nothing but 2 into 2, 4 minus 2 omega square minus 2 omega minus plus omega cube. Okay, so this becomes 4 minus 2 omega square minus 2 omega cube is 1, we already know. So here this becomes 4 minus, if I take 2 as common, omega plus omega square or omega square plus omega, whatever. So 1 plus omega square is 0, I know that. So omega plus omega square is minus 1. So this becomes 4 minus 2 into minus 1 plus 1. So this is what? 4, 5, 6, 7. Now just put the value of n equals to 2 in the options and you will get this. Okay, next one. See, the set of all alpha belongs to R for which W is equal to 1 plus 1 minus 8 alpha Z by 1 minus Z is purely imaginary. Okay, and here it is, the main thing mentioned here is real part is not equals to 1. So here the shortcut trick is, let Z is equal to 1 and the real part of Z is not equals to 1. That is clearly mentioned in the question. So we assume Z is equal to I. So W is equal to 1 plus 1 minus 8 alpha into I by 1 minus alpha, 1 minus I. So what we'll do? We'll do rationalization. 1 plus I by 1 plus I. So this becomes 1 minus 1 plus 8 alpha plus I into 1 plus 1 minus 8 alpha. Denominator is in the form of A plus B into A minus B, A square minus B square, that becomes 2. So since given W is purely imaginary, real part should be equal to 0, right? So 8 alpha is equal to 0 and alpha equals to 0. Got it? Next one. See, this is a very cute little sum. C square plus S square equals to 1. Then we need to find the value of this. So let C plus IS, real part plus imaginary part, is equal to I. Because since C square plus S square is 1 given, so we took like this. So now 1 plus C plus IS by 1 plus C minus IS is equal to 1 plus I by 1 minus I, that is equal to I. I have done this rationalization in the denominator and I have written directly, because after doing so many problems we should be in a position to say that when not in a long term, in the shortest possible way we need to find the answer. That's how the practice should be. Okay, next one. See, for this question, x is equal to a plus b, y equals to some z is equal to a omega square plus b, when we need x, y, z value. So here by substitution, let a equals to 1, b equals to 1. So x becomes 2, b becomes omega plus what? Y becomes omega plus omega square. We know the cube roots of unity. Omega plus omega square is minus 1 and z becomes omega square plus omega, that is minus 1. Okay, so we write the value of x into y into z. X, y, z, that is 2. Okay, next. See here, if mod z1, mod z2, so on is equal to 1, then we need the value. So instead of taking all this, let n value equals to 2. Then mod z1 plus mod z1 is equal to mod z2 is equal to 1. Also z is equal to 1 and z2 is equal to I. So just by substitution, z1 plus z2 by z1 inverse plus z2 inverse is equal to 1 plus I by 1 minus I is equal to what? By rationalization we will get a 1 here. Okay, since they are conjugate. Next. See here, we have to find the value of this much big expression. Okay, so instead of doing this, let n equals to 1. So only first term is enough for us. 1 plus 1 by omega, 1 plus 1 by omega square. So this becomes 1 plus omega square by LCM and all. This becomes 1 plus omega. So 1 plus omega square from cube roots of unity. Okay, so omega cube is 1. Now just put this n equals to 1 in the option and you will get the answer. Over. Next. See, if 1 comma a1, a2, a3, so on are nth roots of the unity, we need to find the value of this. Okay, so again a small shortcut trick. Let's take n equals to 3. Then a1 is equal to omega, a2 is equal to omega square. So from this 1 by 1 minus a1 plus 1 by 1 minus a2 is equal to 1 by 1 minus omega plus 1 by 1 minus omega square. So by LCM and all, 1 minus omega square plus 1 minus omega by 1 minus omega square means 1 into 1, 1 into omega square, and next omega into 1 minus omega plus omega cube. Omega cube is 1, I know that. So from the numerator 2 minus omega plus omega square by 2 minus omega plus omega square. This is 1. Now just put the value of n equals to 3 in the options and you will get the answer. Over 3 minus 1, 2, 2 by 2 is 1. Next one. Okay, see. If 1, z1, z2, so on, zn minus 1, nth roots of the unit. Again, same story. I will take let n value is equal to 3. Then z1 is equal to omega, z2 is equal to omega square. So now 1 by 3 minus omega plus 1 by 3 minus omega square is equal to by LCM 3 minus omega square plus 3 minus omega by 9 minus 3 into omega plus omega square plus omega cube. So 1 omega plus omega square is minus 1, omega cube is 1, and here also omega plus omega square is minus 1. So by calculation 7 by 13. Now just put the value of n equals to 3 in the options and you will get the answer. Okay, next. So in this way we have finished the shortcut tricks for these complex numbers. Okay, this is helpful. These shortcut tricks are helpful not only for this IIT, okay, but it is also helpful for the state board exams like AP MSET, Telangana MSET and all these things. So main thing for this, first we need to, what is the purpose of learning a shortcut is we have to save some time for other tough problems. We can't say that all the 100% problems will be easy, or we also can't say that all the 100% questions will be attempted by everyone. That is the reason percentile is given, not percentage. Okay, because for example in 100 questions, if the topper is able to answer 80, then we should be also able to somewhere near like 70 to 80 in between, so that we will also get this good score. So learn these shortcuts in such a way that out of 100 questions, for example out of 100 questions, 50 questions will be done easily based on shortcuts, and some 20 questions will be done based on static questions. Okay, so make sure that we have learned it in a easy way, so that it will be helpful to fetch you more marks. Okay, so please do subscribe and also comment which other chapters you need or any other subject help, so that we can upload these videos. Thank you so much.